I noted in a discussion with Eric Weinstein, the physicist, that he had observed there's been almost no progress made in physics for such a long time. Any thoughts on that?
Mm-hmm. I get it. There's been, I'd argue a bit about the lack of progress, but I'd say, and I'm sure he'd say the same, that there's been great progress in mathematical modeling and such. But in understanding at the most fundamental physics level, yeah, there's been a very definite, you could say, stagnancy since Schrödinger and friends and, you know, the great age of the last generation of great physicists. Yeah, I tend to agree with him. And the explorations I've had around this, and really why we're here and doing this little video today, how to say, those explorations for me were quite frustrating, and seeing that not move over the history of the last century, really. I think a lot of it's due to the compartmentalization in academia. I think pretty much every branch of science, if you dig deep down into it and get to the real core experts of it, they'll tell you where things kind of get fuzzy and uncertain, and where they don't know if they're really on firm ground. And their public pronouncements, and even not even their public pronouncements, their pronouncements to fellow academics and other departments of science, are a little bit limited in that they have to make sense to these guys. So they have to express in a way that makes some sense. So there's a certain dumbing down there immediately a little bit. And then when it gets to public communication, the dumbing down can get quite heavy. So then the public notions of things are quite different. But the thing is, physicists then assume that, or not physicists, every department of science assumes that every other department of science has it right. So they're happy to base their things on it. I mean, one example is Mach working back in the day with the considering the scale of the universe and the whole universe as a single functioning thing, and trying mathematical models based around the size of the universe. And he takes what the astronomers tell him as being, okay, that will be the size then. And then, of course, the astronomers get better telescopes, see further, and again pronounce on that size. Now, get into the details. They'll say, we never said it was that size. You know, we said based on as far as we can see, etc., etc. And there's the disclaimers, and that's where things can get a bit fuzzy. But their pronouncement gets picked up by other branches of science as an absolute, and so on. And you get the same thing from particle physics to field theory physics to across to biology, and everyone's kind of taking everything that comes from every other branch of science as solid information. But it's not that solid if you dig down into it. And knowing where it's not solid can help perception and working out things, and, you know, things that seem strange or impossible or unintuitive might actually be quite logical and intuitive, actually.
So the point that you had mentioned that I remember was physicists are still stuck in the notion of particles. Who was the Greek philosopher that came up with the atom?
Democritus, but sort of via Aristotle. I blame Aristotle.
Yeah. So just explain that, Aristotle, that people are still looking at it from Aristotle's perspective even now.
Well, if you consider astronomy before it, the epicyclic model, the geocentric models of the solar system, or they wouldn't call it the solar system, the heavens around the Earth, based on the core notion of Aristotle was the Earth's in the middle of it. That was, you could say, the core, generally even not even particularly talked about, fundamental kind of assumption, you know, unconsciously accepted paradigmatic assumption. That's what that is. And Copernicus, of course, got the notion, you know, he listened to someone who told him, look, guy, Earth is not in, you know, Earth is in the middle. I mean, so it's not in the middle, you know, it's the sun maybe is in the middle, things going around that. And Copernicus came up with a model of it based on circles, which was the basic mathematical model used in epicycles. And it, of course, was a lot simpler, just one circle per planet instead of a little cluster of them. But mathematically, it didn't work out that great because, as we know now, he needed to adjust the circles a bit. They needed to be ellipses, which got nailed later on. But he had, you could say, a model that's a hell of a lot closer to being able to get you to the moon. But then Tycho Brahe, he took the notion of the planets go around the sun. Great, he had that notion. But he left the core Aristotelian assumption there of the Earth's in the middle. And so he still had the Earth in the middle. So his model ended up being very complicated, very unworkable, and so on. And for me, where physicists have got stuck in the paradigmatic journey, they've also shaken up a lot of the notions of Aristotle and, you know, outright flat disproved a whole lot of the ideas. I say to a physicist, you're an atomist, he'll say, nonsense. You know, we've completely disposed of that. Look at the whole quantum thing. It's completely destroys Aristotle. And I said, sure, but it's a bit like Tycho Brahe's model. It doesn't take away the core center. And the center is the basic assumption that existence is composed of big empty space with little bits of something bouncing around, flying around in it, being present in it. And that core assumption is very much like Tycho Brahe gets, okay, the planets go around the sun, but then he has to have the sun go around the Earth. He keeps the core error. And for me, that's what physicists have done. This is why there's a split paradigm. They've got the classical paradigm for certain scales, and then suddenly at a different scale, whoops, the rules all seem to change. The way it works seems to go all different, and we've got to have a separate paradigm for things at a different scale. Now, for me, that's something that I'm amazed in a way that sticks in academia and keeps there and so on, because I come at this from a more Oriental informed end of things, where one pretty solid philosophical principle is that existence is self-similar at many scales. So pretty much any phenomena you describe at any scale you should at least be able to point to some kind of analogy at some other scale. And that's where the quantum paradigm wasn't really out of thinking and philosophy and such. It was driven by the mathematical models, very much like the idea of crystal spheres with planets embedded in them going around the Earth, very much came out of interpreting the mathematical model of epicycles. And of course, physics does have this odd thing of making, the word theory implies to most people some level of understanding. It's true in the sense of, say, Boyle's law. Boyle gets the idea of corpuscular motions, little things moving around and bumping very fast together in a liquid. And from that, he comes up with, okay, if things carry on and then in a gas they're bumping around, and that's the dynamics of it, what would mathematically model that? And then he develops the mathematical model from his understanding. But to go the other way around, as the epicyclists did, look, we can time it, we can do these diagrams, we can tell exactly when Venus is going to go retrograde. And you say to them, but why does Venus go retrograde? And there we've got a great mysterious rule, you've just got to accept it. The epicycles say so, the observation says so, the experiment says so, you've just got to accept it. And if there is some explanation, well, the crystal sphere in which it's set wobbles and goes back again, or something like that. And at that point, you're dealing in woo. And woo, physics is in exactly the same situation with the quantum. You must just accept it. The experiments show it, the models show it. That's the kind of statement they say. And that's what they're pressed to say. But if you fix the paradigm, if you finish escaping Aristotle completely, I would suggest it's not so woo, it's not so strange. Sense can be made of this. And then you get a glimpse of the real mystery, the real final inscrutable, you could say, or the next level of inscrutable.
So let's go into that. What do you propose is the actual structure of the universe? How would you explain it?
Well, okay, let's just ring this. The direction I come at it is informed from more Eastern sources and Eastern attitudes of philosophy than Western academia, global academia is, because that rules the East too now, is dealing in. And if we take that principle I suggested, that existence is self-similar at many scales, that gives me a hint there's something to look at. And if we take another principle, we'll steal one from the West, because I've had a nice grounding in both. You've heard of Occam's razor, the simplest, most direct, like add an extra element, create something unnecessary in your model at your peril. So if we start there, from these we get the basic fact. Let's start with the most basic fact, that we exist, that we are having this conversation, that this is happening, that this is arising, that existence seems to be, etc., indicates to me pretty solidly, I think it's inescapable, that one brute fact we must consider is that there is something. And we don't have to be broader than that, just something. Like, maybe the simulation guys are right and we're all running on a computer substrate of some sort. Well, you've got to have something to do the computations. There's something. And then let's keep the Occam's razor really tight, and it happens to line up with what the Eastern philosophies tend to suggest, is let's say, okay, let's admit to that there is one thing. How about that? One. And then to go assume two things, or one thing divides into two things, and so on. The main reason for not doing that would be Occam's razor. There's no need to propose two things. Or if there is, it'll emerge and we'll then have to, or whatever. But let's try keep it to the one. And my core training, several years, it goes even with the name, if you care to look up my name attached to this video and take that as getting a name given to you by someone whose will you're submitting to, someone you're taking the guidance of, in the old archetype of sannyas, discipleship, and so on. The name is a challenge, and it's a challenge of an area that you should study, kind of thing. So I was given the name of a name that set me on a study of Advaita very deeply. Well, I was already on a study, but it made it the focus, the center of much of my work. And in terms of that, it is said that existence arises, all the apparent phenomena arise from the motions of the one substance. And the characteristic of that one substance, its prime characteristic is, it is undivided and indivisible. It's very much at the root of Advaita philosophy. The word Advaita itself, Vaita gives us, through the way language moves, division. And ad is the negative, Advaita, no division, undivided. So one undivided, can we make it work with that? In mathematics, physicists would call this a single quantum object. They say it's the wave function of everything is the model of that. And I'll go with them on all of that. So one thing, one substance. Now, one thing we have from experiments and so on is stuff called fluids and superfluids. We can probably get some understanding of this just from the regular behavior of many fluids, but superfluid studies, cooling down liquid helium to extreme levels and playing with it. There's all sorts of lovely stuff worth looking up and going and looking at of what they're discovering there, especially around vortices in superfluids. Now, superfluid's characteristic is it's one object. It's one quantum object in that language. So the inversion of Aristotle is, Aristotle sees it as bits of something bouncing around in the nothingness. And even physics, where it's gone now, you could say they had the ether, but the ether even was still something also within that nothingness, like an extra element which allows light to travel through it. So it's still keeping the core Aristotelian assumption. And then they discarded ether, and then it was Weinstein, who you mentioned earlier, mentions, well, they kind of brought it back, and the spin-ors and the Hopf vibrations and the fiber bundles, and they're putting a lot into this nothingness and a lot of properties and qualitative qualities. So that's kind of building up the ether again, in a way. And for me, it's just not going far enough. You must go all the way with it. And it's still seeing it as empty space with things in that space. Forget that. One thing and its movements within it. So the inversion I'm suggesting, instead of empty space with bits bouncing around in it, it's one thing, one substance. Mathematically, I think modeling it as a superfluid / supersolid, somewhere around there looks promising. It has strange properties, and it has a strange lack of properties in a way. I don't think it has mass. I'm not too convinced about momentum, but it has motions. And this one superfluid, the movements of it produce, you could say, cavitations. If you have a vortex spinning and it spins with enough energy, it's going to pop a bit of vacuum, true nothingness in it. And I'm going to suggest that, I suggest that toroidal vortices spinning with a lot of energy, creating a cavitation within them that is a little thread, little loop of vacuum. That's what the string theorist guys are modeling. From their perspective, the other way of having to have something happen within the nothingness. So they need these dimensions and these accumulations of energy to try and squeeze that out. I'm saying it's a simpler thing. We've got a fluid, we've got it spinning, we create a vacuum, and those little vacuums, so little bits of nothingness, literally nothing, are the matter that appears. And this is where, for me, you get riddles all over the Oriental texts, or it reads like riddles, is that the phenomenal world is built of nothing, that there's nothing real about the objects in the world, and so on. And it's a riddle because we view it from the Aristotelian assumption of empty space with the something in it. But that is essentially, it's more like bubbles, you know, like I think for me, if I was imagining what's the physicist's moment of realization with this, like Newton's apple on the head moment, I would say when he's looking at bubbles in a glass of champagne and smoking a cigar, the smoking cigar is going to show him the toroidal vortex, and he realizes that could make a bubble. And you have bubbles arising. The thing I would add to that conception, and again, all right, at that level, if you take that basic notion, motions within a superfluid and so on, some physicists will say, no, we're on that. There's superfluid vacuum theory. Yes. There's various other, ask an AI, it'll give you a list of physicists that have similar notions. Working in terms of toroidal vortices in a superfluid, and you're going to have this connect up very soon in the world of physics, even more solidly than it is already, because of all the great work in condensed matter physics, where they're looking at superfluids and seeing their behaviors and computer modeling them, and then you get lots of little toroidal vortices happening, and it's going to happen. But what they're missing is the other little part of the equation, is the momentary nature of matter. That I'll suggest, and I don't want to, I want to be like Newton and do a bit of hypotheses non-fingo, not suggest ideas too much, but perhaps just from maybe this one substance, if there's any truth to the idea of fourth dimensions and so on, might be that this one substance is appearing from that. It may be increasing, may be growing. That may be the source of the important factor that's definitely there is a pulsation in it, a vibration permeating it, and very, very rapid pulsation. Mathematically modeling it, I think you've got to look at somewhere around the Planck scale, the Planck time, for that pulsation, that vibration. It would be the unit of time below which any idea of time is meaningless. Because what I'm suggesting is that these vortices that are spinning and trying to cavitate a little vacuum thread in the center of them, they manage that cavitation when the pressure of that overriding pulsation is low. So as the pressure comes off, pop, matter comes into being. As the pressure comes on, it squeezes, it clamps all of them shut. All those vortices, they keep spinning. Their motion's there. You know, they're continuing. But until the next low pressure moment of that overriding pulsation, they stay closed, and their evolution is modeled based in mathematics of sort of fluidic motions. And if you look at string theory, all over in the quantum, the suite of mathematics that forms up the standard model and so on, there's a lot of potential vortex dynamics and fluidic calculations. Even just the wave function is a fluidic evolution. So then, because things move slightly, and then next moment, as the pressure comes off, pop, things pop back more or less where they were. Energies have changed a little bit in the meantime. Things have moved a little bit in the meantime. And the one big thing that's moved is where you have large accumulations of matter, which I'm of course suggesting is composed literally of vacuum. On the beat between moments, the high pressure regime, all that matter collapses. Those little vacuum threads. Now string theorists model them, these things they call strings, as one-dimensional. So, and for me it makes sense they would be perhaps very, 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 very tiny, extremely small. But when they collapse, a large accumulation of them together, that's going to displace the fluid around it. And that displacement gives us gravity. This is where, when I've been on Facebook and things and teasing physicists, I say, come on, if you really study the double slit experiment, that it shows a dual nature going on. A particle-wave duality is what it's become called. But you're only forced to that if you're working from, if Aristotle's assumption is deep within you. If, for me, the obvious thing about that is two conditions apply. A detectable condition, call it a particle condition, and a non-detectable condition, call it a fluidic condition. And I'm suggesting these alternate instant by instant, and moments arise. And so when a particle is not observed in terms of Heisenberg, when it in principle can't be observed, because maybe push me more on that a little bit more, because quantum woo is very much concerned, very much involved with the observer, so-called observer effect stuff. Very strange. But if you have a particle condition and a wave evolution condition, and you get much the same. I mean, I'm not arguing with the mathematical models of physics. I'm arguing with interpretations of them that are based in that Aristotelian era of atomism at its very core. Empty space with stuff in it. Even if the stuff in it isn't particles, it's fields and whatever, but it's still something in an empty space is the basic conception. And so I believe studying the double slit should give you the realization that you've got these two conditions. Matter is there, and it's not there, and it's there, and it's not there. It's probabilistic in where it appears again, certainly. It evolves by fluidic motion in between when you see it, which for me, even moment by moment, you know, it's resolving, it's being actual, but then it's being fluidic again. And when I say actual, it's all actual. It's one thing permanently present. Just the motions of it and that phenomenon of the vibration, giving it a low pressure moment where it can do this thing of popping little bits of vacuum into being when it can cavitate. And the TLDR statement of what I would like physicists to listen to and consider and try work on in their models, because it's going to be tricky. There's a lot to do. Is matter consists of momentary cavitations, momentary vortex-driven cavitations in a superfluid or supersolid. That would be the center of what I come to, or the final statement I have around matter and so on. About what that superfluid may be and so on, there's a great area for exploration and conjecture. Some call it consciousness. My view would be that existence is observed every moment, between the moments. All consciousness is one. That one quantum object is one thing. And hence the Eastern ideas of one consciousness being one universal consciousness, all of us experiencing ourselves as kind of a node of that. For me, it links into that, but that's not really for me so much what this video is about. It's about just that physical understanding of how matter arises, that it is momentary, that it is probabilistic. It's yeah, yes, but not that absolutely. And the dynamics, those fluid dynamics, I mean, when they're talking entanglement, yes, there's a vortex twisting between the two of them. And when the vortex collapses, it collapses along its whole length. Yes, it is almost instantaneous. It can be faster than the speed of sound in that medium. And just to kind of rub it in, the solidity, the substantialness of the one substance. I love those physicists who've just done the exercise of calculating from the speed of waves, be they gravitational waves or light waves, same thing. The speed of waves through a medium depends on its Young's modulus, how stiff it is, how resistant, how stiff. Young's modulus, you can go look up the finer engineering definitions of that. But if you calculate the Young's modulus of empty space, it's 20 orders of magnitude. So 20 zeros added on to the modulus of the Young's modulus of diamond. So it is the most substantial solid. It is the substantial solid thing, one thing. And little bubbles appearing in it, little vortex threads, that doesn't divide it in any sense of the word. And it remains undivided, indivisible. And that's what physicists should be studying, is the qualities and the nature of that. And they are studying it, as I said, in condensed matter physics and so on. But conceptually, they're still, I mean, I've asked the AI to look around, because believe me, I would far rather, point to Ed Whitton and say, he aced it, there you are. Or the guy you mentioned, Weinstein, or any of several. I mean, I see so many minds out there that it's still boggling my mind. How come they haven't caught on to this? To me, there's an obviousness to it. And admittedly, until I came to the obviousness of it, it was a 7-year journey of playing dig and poke and dive deeper into particular aspects of the models and get my head twisted around spinners and all sorts of fun things. It was a great journey coming to this. But once I get the basic notion of just that inverting Aristotle, then I spent another few years really looking for contradictions of it, really looking for places where, well, if I'm right with this, then this or that model has, and I don't find anything wrong in string theory or anything wrong in the standard model of quantum physics. I love that stuff, but just the interpretations of them, and hence my little bit to just nudge this stuff for, especially to those who are suffering any kind of quantum roux. Yeah.